Hello everyone. In this video, we will cover the basics of spherical mirrors. All of you have heard and studied about plane mirrors. What is a spherical mirror? So a mirror which was part of a sphere is known as spherical mirror. Now we get two types of spherical mirrors. As you can see in the diagram, we have one mirror whose reflecting surface is curved inwards. So if this is the surface, this part is reflecting and the part behind is non-reflecting. And other type is reflecting surface is curved outwards. So the mirror where reflecting surface is curved inwards is known as concave mirror. Is known as concave mirror, and the mirror whose reflecting surface is bulged outwards is known as convex mirror. So if it is bulged or curved inwards, it is called concave mirror, and if it is curved outwards, it is called convex mirror. The other name for these is concave mirror is also known as converging mirror, and convex mirror is also known as diverging mirror. The important thing to keep in mind is both of these were initially part of a sphere. Hence, together they are called spherical mirrors of two types. Ones which are curved inwards are called concave mirrors, and the ones which are curved outwards are called convex mirrors. The reason behind the names being converging for concave and diverging for convex we will study shortly. Now let us look at various terms related to spherical mirror. Here we have taken an example of, as you can see it, the mirror is curved inwards, so it will be concave mirror. So here we have considered example of concave mirror, but same could be done also for convex mirror. Its reflecting surface will be curved outwards. So the dotted part shows the original sphere. So spherical mirrors are mirrors which were originally part of a complete sphere. We have just taken a section of that sphere. Now the reflecting surface is curved inwards. So it is concave mirror. We have marked various points on this mirror. Let us look at them one by one. The MN represents the reflecting surface. The center of that reflecting surface, that is center of the spherical mirror, is called pole of the mirror. So it is called pole of the mirror and it is denoted by letter P. Mn is the reflecting surface and center of the reflecting surface is called pole of the mirror, denoted by the letter P. Now, this spherical mirror was initially part of a complete sphere. That sphere would have had a center. So, the center of the sphere of which the mirror is a part of is called center of curvature, denoted by letter C. So, the second term is center of curvature. Center of the sphere of which mirror was a part of. Now, the sphere would have had a radius. The radius of the sphere of which the mirror was a part of will be called, yes, as you can guess, radius of curvature. Radius of curvature. So pole is the center of mirror or center of the reflecting surface. C is the center of curvature, the center of the sphere of which the mirror was a part of. R, which denotes the radius of curvature is the radius of that sphere. And we can clearly see that radius of curvature r is the distance between points C and point P. The next term we need to look at is principal axis. Principal axis. We can see just one line which is passing through the two important points that we have studied. Point C, which is the center of curvature, and point P, which is the pole. So the straight line passing through the pole and the center of curvature of the mirror is called principal axis. So it is a line joining or passing through center of curvature denoted by C and pole of the mirror denoted by P. Let us move on to the next point, which is denoted by F. It is called principal focus. If we consider a set of parallel rays incident on the mirror and the rays which are parallel to the principal axis, then after reflection all of them pass through a singular point. So if let's say we have a ray here passing parallel to the principal axis and it gets reflected by the mirror, it will pass through this point. Let's say we have another ray, it passes through again the same point. So such a point where all the rays parallel to the principal axis after reflection pass through is known as principal focus, denoted by the letter F. Now in case of concave mirror, the rays actually pass through this point. But in case of convex mirror, the rays appear to emerge from this point. We will study that in detail shortly. Now, it is observed that point F is the midpoint of C and P. So, midpoint of CP is point F. So, we define focal length and principal focus. We define focal length as distance between the pole and principal focus. So distance between the pole and principal focus is defined as focal length, denoted by small letter f. This distance is half of radius of curvature. Hence we can write f is equal to r upon 2 because f is midpoint of CP. Let us recap all the important terms that we have studied. First one is pole of the mirror. The center of the mirror is called pole of the mirror. The center of the sphere of which the mirror was a part of is called center of curvature, denoted by C. Then the next term is radius of curvature, denoted by the letter R, radius of the sphere of which the mirror was a part of. Radius of curvature. Now we consider a line passing through center of curvature C and pole of the mirror P. That line is called principal axis. Now all the rays parallel to the principal axis after reflection pass through a unique point, pass through just a single point that we call principal focus. It lies exactly in between the center of curvature and pole of the mirror. So the distance between the principal focus and pole is termed as focal length, and because f is midpoint of CP, we can write the expression f, the focal length, is half of radius of curvature. Let us continue. Important task in this chapter is to draw ray diagrams for various scenarios where objects are kept in front of a concave or a convex mirror. Let us first focus on concave mirror. Now, laws of reflection are always followed regardless of the surface. Laws of reflection are followed in case of plane mirror and also in case of spherical mirrors. But considering any rays, it will be very difficult to draw ray diagrams. So we have set of rules which help us in drawing ray diagrams. So let us look at those rules one by one. But before starting that, it is important for us to properly be able to draw a spherical mirror in our notebook. So there are certain dimensions or measurements which you should follow. The first one is the radius. So in your compass, you should measure out length of 6 centimeter. This will act as the radius of our spherical mirror. Now, while starting the process of ray diagram, first and foremost, you should draw principal axis. Once you draw principal axis, mark out point C, which if you recall is center of curvature. Now, once you have 6 centimeter length in your geometric compass, place the metallic end on C and draw an arc. Now, when you draw the arc, you should draw 3 lines above the principal axis and 3 lines below the principal axis. So, the total height of your mirror will be equal to 6 lines in your notebook. So, height of mirror 6 lines of notebook. Once you do that, confirm that length between C and mark here point P, which will be pole of the mirror. Confirm that this length CP is equal to 6 centimeter. Now using a ruler, mark out the midpoint of C and P. That will be our point F, which is the principal focus. So if you calculate the focal length denoted by F will be, formula for focal length is R upon 2, that is focal length is half of the radius, it should come out to be 3 centimeter. So this way the ray diagrams you draw will be neat and proper and easy to understand. Practice this, and now let us look at the rules for drawing ray diagrams. So the rule 1 is, if an incident ray is parallel to the principal axis, so this is the incident ray parallel to the principal axis, then the reflected ray, this is the reflected ray, passes through the principal focus. So this is the point which is principal focus, and incident ray parallel to the principal axis after reflection passes through the principal focus. So this is the first rule of drawing ray diagram. Rule 2. If an incident ray passes through the principal focus of the mirror, so our incident ray is passing through the principal focus, the reflected ray is parallel to the principal axis. So see, this is exactly the opposite of the first rule. In the first rule, incident ray was parallel to the principal axis, but reflected ray was passing through the principal focus. In rule 2, the incident ray is passing through the principal focus of the mirror and the reflected ray is parallel to the principal axis. So, incident ray in the first rule has become reflected ray in the second rule, and the reflected ray in the first rule has become incident ray in the second rule. Now on to the third rule. Rule 3 is, if an incident ray passes through the center of curvature of the mirror. Center of curvature is this point denoted by C. If the incident ray passes through the center of curvature of the mirror, the reflected ray traces the same path back. So this is the incident ray. It will retrace its path. So it will go back along the same path. So reflected ray will go back along the same path and pass through the center of curvature. So incident ray and reflected ray, they are coinciding with one another. The reflected ray traces back the same path.